All right, I believe we are live. Welcome, everybody, to our third weekly sky update. Our weekly sky updates here are astronomy-themed shows where our student astronomers here from our UNT Planetarium and Astronomy Department actually present to you a sky update as to what you can see in the night sky tonight and what you'd be able to see over the course of the next week. We have a very cool show set up for you today where Ashley, our student astronomer, is going to be giving you a tour of the night sky and things you can see both late at night and early in the morning. And these are going to be things that you do not necessarily need a telescope or binoculars to see. These are things you can see without any kind of sort of magnification or anything like that. Stuff you can see from your backyard, even if it's in a light-polluted area. Before we get started, we do just like to remind you that we are unable to really generate revenue through normal means during this time. So we're offering these awesome online services where our student astronomers are coming up with new videos. We're actually going to make pre-recorded videos that we're going to be uploading onto our YouTube channels and our Facebook page. We've also just worked out new astronomy trivia. So on Wednesdays, we're now going to be offering astronomy trivia. It's going to be a live interactive game that we're going to host through Kahoot, and that's going to be pretty cool. And what we're also going to be rolling out soon is an Ask an Astronomer Q&A session. With our Q&A session, what we'll be able to do is answer any kind of questions that you're not able to ask anybody else, or maybe they're questions about the universe or sort of deep sky objects like nebulae, or maybe how planets are formed, or questions about chemistry or other kind of science things as well. So those are going to be more kind of upcoming video services that we provide online through streaming. However, we're unable to generate revenue normally through this time. So what we're doing is we're actually collecting donations online on our website. The link is in the description for this live video below. So you can check that out in the link below. And what you can also do is check out our other pages. We've cross-shared this live feed to both our UNT Sky Theater and our Rafus Urban Astronomy Center page. If you've been to either of those places and you're familiar with what we do, we have a planetarium where we have experts on astronomy and the planets, and we guide you through night sky talks and live shows. And then we also, of course, have our astronomy observatory facility where we have telescopes, and all of our experts are out there, usually when we're not during a pandemic. We're out there 2 or 3 Saturdays a month giving lectures and star talks and showing you what we can see in our telescopes and teaching you how to use telescopes. So we're going to be offering these services online in another way, and in order to maintain that and actually make our services even better when we do come back to normal life, then we were going to be collecting donations. So how that's going to work is we're going to be able to create possibly a box office at our planetarium. We're also going to be looking forward to making an online ticketing system to make it easier to buy tickets to shows. And we're going to try to make sort of prizes that we can give out if you are able to give out donations, or if you win games at our trivia events that we're going to be doing on like Wednesdays, for example. Then we're going to try to basically keep you around. We are going to be offering any kind of online astronomy service that you can kind of need. So feel free to message us or comment below if you have any questions about the space or about anything else that UNT Astronomy can offer you as a service. Go ahead and hit us up. During our actual live video today, Ashley is going to be talking about everything we can see in the night sky, and I'm going to be answering any questions you might have in the comments below. So here in just a moment, maybe we'll wait about 2 minutes here to see if anybody else kind of floods in. We are going to get started on our live stream of our night sky update. All right, And I just wanted to say one more time that in case you're just joining us or something, or if you missed the first part of what I'm saying, what we're doing today at 2 o'clock and at 7 o'clock is we are doing our weekly sky update, where we give a night sky talk of what we can see in the sky tonight or early in the morning. Ashley, our host, is about to start. And all right, I'm going to turn on our video feed for Ashley here, and you can take it away whenever you're ready.
Awesome, thank you, Cade. So yeah, there's a lot of things going on here. Not just in the world, but here in our planetarium or out in our homes, in our home planetariums, which you can have your own home planetarium too if you use the software that I'm using today. In our previous videos, we showed you free software you can download called Stellarium. Super helpful software, very easy to use. The user interface is very friendly. So to get started, so when if you decide to download this at home, this is essentially what you're going to see if you open it up during the day, because when you open up Stellarium, it's going to be basically your live sky, what the current time and date. But if it's not, you can go over here to the left side to our time and to our location window. We'll do location first and then time and date. So you can get location from network. You can just type in Denton right here if you'd like. There are a couple Dentons. So you can see that I think there's a Denton in England somewhere in Britain. Yeah, so we got Denton, United States here. You can also choose from any other location in the world as well. There's a lot of different locations that you want to take a look at, because not everyone's sky is going to look exactly the same depending on if they're, if someone is living up north in the northern hemisphere versus someone looking at a sky in the southern hemisphere on Earth. So yeah, you can choose your location here. All right, so we're in Denton. Whenever you choose your location, that doesn't change the landscape of the ground. That's actually a separate setting. You can actually change the landscape. If you want a snowy scenery, you can get a snowy scenery. I chose one that is located in Paris, like it's like a country scene in Paris, and to me, it's a pretty good representation of what Denton looks like. If you've been around here, a bunch of minus the cows, of course. There's not a lot of cows here. All right, so let's go to the time and date. Time and date window right here. So I just popped it right down here. So it is going to be, this is today, this is the current time, June 13th. And the time here is going to be your 24-hour military time. All right, so it's currently 2:11 here, or PM. Nice thing about the date and time, especially the date, is you can go to a certain day, maybe your birthday or something, or maybe a past or future anniversary, to see what the sky will look like on that day. So I think that's pretty cool. So I'm just going to stick it down here, just so it's out of our way a bit. So since this is a live time, if you go down here to the bottom of the screen, you're going to have like a fast forward, backwards play and pause button. And so it is rolling in seconds in real time. We don't want to sit here all day and wait for the sun to go across the screen, so we can fast forward a bit. So I'm gonna do that here so we can take a look at the apparent motion of the sun going across the sky. You have to click it a couple times for it to really start moving. All right, so we see that the sun moves across the sky from east to west. Remember, the sun rises in the east and sets in the west. The sun can be used to help you with directions during the day, if you know which way it rises and it sets. The sun actually kind of goes across the sky here, and it follows a line. So this line is called the ecliptic line, and I can actually use some of the buttons on my keyboard to just kind of bring it up. So there's my ecliptic line. So I press the comma button in this case. So the ecliptic line is the path that the sun follows every day, along with it's also the relative plane of our planets. So you'll see the zodiacal constellations on this line. You'll see the planets following roughly on this line as well. All right, I'm going to keep going forward. You'll see some of the stars pop up. All right, so it's still pretty bright since it is summer. It doesn't fully get dark until probably 9:30 or so. So we're just going to bump it up to say like 10 o'clock, so 10:30. Okay, so it's pretty dark around 10:30. All right, so when you look up at your sky, you're probably not going to see this many stars. I did bump down the light pollution a bit, which is also another setting. If you go to the sky and viewing options window, it's going to be the first tab under sky, and you can actually change the light pollution. So Den is actually considered like a level 7, which is pretty high light pollution. I bumped it down to 4. Just so we're not completely overwhelmed with stars, and also not like we can't see anything. So we can see a fair amount of stars. But remember, the stars I'm going to show you right now are stars that we can see in our light polluted sky, right? So it's, I mean, I would hate to show you stars that you can't even go out tonight and look at, right? All right, so the first thing that we're going to do, since during the day we can use the sun to see where east and west is, but at night it's really hard. So we have to use the stars to navigate our way through the sky. So we're going to find the Big Dipper first to help us find north. Okay, so I'm just going to click and drag just to look straight up in our sky and kind of zoom out a bit as well. So the Big Dipper, could you guys see the Big Dipper? The Big Dipper is right here. It looks like a big spoon or a ladle. Some, depending on where you are in the world, even some cultures saw it as like a wheelbarrow. Yeah, so we just call it the Big Dipper. Looks like a big spoon. So what we're going to do is we're going to go to the edge of the spoon here. So I'm going to click on this dipper here. So the dipper, as you can see, when I clicked on the Big Dipper, or the handle of it, it brought up a much bigger constellation. So the Big Dipper is actually an asterism. So that's just this part right here. So the asterism, the asterism is a name for a modern grouping of stars. It's going to be the brightest stars in that constellation. So the Big Dipper is kind of like the bottom rump of the Big Bear, or Ursa Major. Okay, so when I clicked on it, you can see some information here on the left side of the screen. The star that I happen to click on is Alkaid. And Yuma, looks like Yuma, that means the Ursa Major. So it gives you some good information here. Here in Stellarium, you can also tweak and customize how much information you want to see on the side of the screen here. You can pull up a bunch of information, but I narrowed it down to just kind of the important specs of these objects. Okay, so let's go back to our Big Dipper. So our Big Dipper is right here. Remember, it's an asterism. It's not actual constellation. And we're going to go to the edge of the pot right here. So these two stars, these are called our pointer stars. And we can actually just draw a line straight through those two stars. And I'll try to be very careful with my mouse here to draw a very straight line straight down to this star here. That is Polaris. So I just brought it up. So there's Polaris. This star, or the North Star, is this little A means alpha, means the brightest star in Ursa Minor. So Umai is Ursa Minor. There's Polaris. As you can see, the stars in Ursa Minor are not very bright, as you can see. So that's why we recommend finding the Big Dipper first to find the North Star in the Little Dipper. Okay, so now that we know where north is, we're stretching our necks behind us here. I'm going to drag the screen so we're actually facing north now. There we go. So there is north. Bring up the constellation points too. All right, so the North Star is a very steady star in our sky. It doesn't move around. What appears to us, it doesn't move around to our eyes. It's a very steady star. So as the Earth rotates, it looks like the stars are going around the North Star. It's called the North Star because if you were up further in the northern hemisphere, if you were like say in the North Pole, the North Star would actually be right above your heads. The star right above your head is called the zenith. I'm not saying the North Star is called our zenith star, but if you were in the North Pole, the North Star would be right above your heads, and that would be zenith. But since we are just a bit further down in the northern hemisphere, it's going to be further down in our closer to our horizon here. So all those stars that go around the North Star are called our circumpolar region. So these are the stars and constellations that never rise or never set. So I'm just going to, I'll pull up that region. So you got a bunch of markings you can choose from. I'm going to choose circumpolar circles. There is our circumpolar circle. So there's a number of constellations and stars within this region. So if I fast forward through time, you can see the objects and stars moving around that central point there. So you can kind of imagine as the Earth rotates, you can pretend like as if you were sitting in a chair that turns, right? So if you're turning really fast in your chair and you look straight up, it doesn't look like it doesn't appear that the what you're looking up at, it doesn't move as you're turning around in that chair, right? So that's kind of what you're seeing here. All right, so let me just pull that down. All right, so now that we know where north is, I'm just going to switch back to south because most of the objects, including the ecliptic I showed you earlier, is going to be located in the southern sky. All right, so we're going to do a little star hopping today. This will be the last star talk of our springtime stars because we are in summer. The springtime stars and constellations are starting to set now. And next week we'll talk more of what we can see in our summer sky. So I'm not going to reveal too much of what is in our summer sky. So this will be the ending of our spring constellations. But we can still see them high up in our sky at let me push it back a little bit more at 10 o'clock. All right. So star hopping. We're going to start with the Big Dipper first. Big Dipper is really great. Good reference. So the first saying goes arc to Arcturus. So you see this little arc here in the handle of the Big Dipper? We can just draw an arc through the handle there, and it can swing us to this big bright star here, which is named Arcturus. So arc to Arcturus, that is the brightest star in the constellation Bootes. I might be butchering that name. I've heard a number of pronunciations, but I'm pretty sure it's, I think it's Bootes. So yeah, this is the brightest star in the constellation Bootes. It kind of looks like a human figure. If you really look hard, it kind of looks like a human figure, but if you're just looking at it, it looks like an ice cream cone, right? So the Alpha star right here, this is Alpha star. It is a, well, it's kind of debatable if it is a double star. I looked that up and it's debatable. You can look that up more if you'd like. But the brightest star we see is going to be Arcturus, Alpha Arcturus. So this star is actually pretty close to us. If we're talking like astronomical distances, it's around 36 light years away. So that's how long it takes for light to travel in a year. It takes 36 years for the light from that star to travel to get to our eyes. For example, our sun is 8 light minutes away. So if our sun were just to poof out of existence and just delete itself, we wouldn't notice until 8 minutes later. So our sun is 8 light minutes away. This star is 36 light years away. So pretty close. This constellation, his name is Bootes, but it's probably easier to remember him as the Bear Guardian or the Bear Watcher because he is right next to Ursa Major, the big bear. All right, so The next one I'm going to do is we're going to spike down. We're going to just go spike down to this next star right here. So yeah, it looks like a human, an ice cream cone, or a spike, because he does form a little spike right here. We can just spike down to Spica, and that is going to be a bluish star. I don't know if you noticed, but actually the text here on the left side of the screen changed colors. So it depends on the color of the star. Arcturus is a bit orangey or yellow, while Spica is a blue star. It is actually a blue giant star. So blue stars are actually going to be much hotter and younger than the red stars. Usually we associate red, orange colors as something being very hot, because if you've taken an art class, we consider those the warm colors, where the cool colors are like, oh, blues and purples. But when we're talking about stars, it's actually quite opposite. So the red stars are going to be a lot cooler than the blue stars. To help you remember that is, if you think of a flame, a candle flame, the tip of the candle is going to be kind of reddish or yellow. It's going to be cooler. But when you go down to just the very top of that wick, where the flame starts, it's going to be blue. So that's actually the hottest part of the flame. So hot stars are blue, cooler stars are going to be red. Not cold, but they're cooler, right? So Spica is around 261 light years away. So that is a bit further than 36 light years. But still a very bright star in your sky that we can see at night here. It is a binary, a double star, so a binary star system. If you zoom in really close, we won't be able to see the two stars because these stars are very close to each other. So from here on Earth, it actually looks like one star to our eyes. So its companion star, so his buddy, I should say, his friend, his companion star, is actually only about 11 million miles away. So think about it. That's actually closer than, let's say, the Sun and Mercury. So these are two stars. As you know, stars have a lot more mass than planets do. These two stars orbit around each other very fast. So they actually orbit around each other every 4 days or so. They're just swinging around there really fast. So that's going to be Spica A, so the alpha star, and his companion would be Spica B. All right, so the last one I'm going to show you. The last star I'm going to show you is going to be in the constellation Leo. So let me just zoom in a bit. And we are going to leap to Leo. So we're going to take this star and we're just going to go straight across here. It's another bright star. So this star is actually not called Leo. His name is Regulus, and it is in the constellation Leo. Leo looks like, if you look up in the sky, you'll see a backwards question mark right here. So it looks like a backwards question mark. You should be able to see it if you look closely. It's pretty faint, but you should be able to see it. Some people say that it looks like a mouse, or to me, it looks like a lying down lion or a sphinx. Excuse me. So yeah, this star, Alpha Leo, also has a companion star as well. So there's an Alpha and his little friend. And these guys are pretty interesting. So these two stars, the Regulus system. It's one of my favorite stars to talk about, because this Regulus is only about 79 light years away from our sun. So he's pretty close. Let's see. So his companion star is going to be pretty small. He's only going to be like a white dwarf. So it's he's going to be smaller than our sun. Let's say that. So the distance between Regulus and his companion star are only about 32 million miles away from each other. That is the distance between our sun and Mercury. So can you imagine our planet Mercury being another star in our solar system, and what that would look like in our sky here on Earth. So pretty crazy. So these guys orbit around each other extremely fast as well. Um, and also, stars can have a rotational period as well. So our sun rotates every 27 days, which is it's pretty good for the mass of our sun. Excuse me. Since stars have so much more mass, the faster they rotate, the more oblate or oblong they become. So they're not nice spherical stars, but they become like football shaped stars. So Regulus um, actually rotates um, every six. Sorry, excuse me. He rotates very fast, about every 16 hours, not 6 hours, every 16 hours. So it's extremely fast for a star. So if Regulus were to actually rotate just a bit faster, he would end up killing himself or tearing himself apart. So if you imagine if he were to tear himself apart, what that would look like in our sky. He would maybe just be kind of this shimmery blob, maybe. But who knows? It's a good thing that he doesn't rotate any faster, or else, we wouldn't have a Regulus anymore. All right, so those are the three stars that you can find tonight. These guys are starting to set because, like I said, we're in summer and these springtime constellations are leaving. But these three bright stars in the sky, Arcturus, Spica, and Regulus, make a big triangle. This is another asterism called a spring or springtime or spring triangle. So I can bring up a set of asterisms that you can see. So I press Alt A. There we go. So I can't just bring up individual asterisms, so we can see just kind of a bunch of them up right now. So as you can see, we can just make a big triangle using those three stars right here. There's another one that makes up a diamond here. This is a springtime diamond. I don't recommend trying to find the diamond because the stars are really faint. You can't really make up a diamond in the sky here in Denton, but you can make this big triangle. Kind of looks like a right angle triangle. All right. So I'll bring those guys down. I'll bring up the artwork too. So if you kind of have a hard time seeing like the Bear Guardian, if you're having a hard time seeing Virgo, I got their artwork up here. And there's Leo the Lion. All right, and right down here we have a constellation that's coming up here. This is going to be the beginning of our summertime constellations. I don't want to get too much into it, but I just want to make a shout out to Scorpio as well. You'll see a very obvious hook right here that makes up his tail. Yeah, it's hard not to go too much into him. All right, so there's one thing I want to show you guys. That's going to be, I guess it's kind of an event that's going to be happening here later in the week. Let me bring down these constellations. I do want to show you some planets. But here on the 19th, let me just bump it up to the 19th. And this is going to happen like really early in the morning, okay? So if you got a morning, if you're up earlier in the morning for a jog before it gets too hot, or if you had to go to work early in the morning, make sure you look up before you get in the car and go into work. So let me just bump it up to almost 6 o'clock in the morning, kind of early. All right. So like 5:30-ish. There we go. All right. So over here, these look like two big stars, right? So that's actually the moon. Yeah, that's actually the moon that just popped up there. So I want to center on the moon. Double click on it. Center on the moon. I can zoom in. The moon should be rising. This is going to be a waning crescent moon. Yeah, waning crescent moon. I was going to think about it for a second. Yeah, waning crescent moon. It's going to be very thin. It's about 4% illuminated. You should be able to see just a very small crescent early in the morning. But one thing I want to point out here, going to be right above the moon here on the 19th, is Venus. So Venus, if you got some like good binoculars or a telescope or just even a backyard telescope, if you zoom in on him, he will also be a crescent Venus. If I click on him, it'll be easier. There we go. Pause it. So there is Venus, also a crescent. So Venus should be just popping up right above the moon on the 19th. He'll look like a really bright. Venus is also known as like a morning star because most usually you'll see Venus up during sunrise. But also, there are planets other than Venus. There are planets out too. It's over here. We have Jupiter. Jupiter will be out towards the south while the moon is rising in the east. Center on Jupiter. We can zoom in on Jupiter, and you can zoom in by just using the scroll button, like little scroll button on your mouse. And the more you scroll in, you can actually see more detail on the planet or on the planets that you choose. So it's really cool. And you can also see his Galilean moons. So these are the moons that Galileo first spotted when he discovered Jupiter. This is, and what's also really cool about this is that this is in real time. So at real time, as in like if you were viewing this on the 19th around 5:30 in the morning, Jupiter's red spot will just be showing up right here. And you can, oops, you can actually kind of see it rotate. I don't have it centered in though. Maybe that might work. There we go. Yeah, you can actually watch the planet rotate here. Also, some of the moons, you can also zoom in on the moons as well. What's an Io? Io is a very fascinating planet because he's very orange and yellow in color because of, you can think of Io as like a giant sulfur field. So that's why he's so yellow, is because the volcanic activity on the moon. A lot of sulfur gives it that yellow color. And there's Io. All right. So with Jupiter, let me go back to around 6 in the morning. And we're 5, there we go. So Jupiter, and then right next to Jupiter will be Saturn too. You can also see Saturn's nice rings. You zoom in. So these aren't all the moons of Saturn and Jupiter because each of them have about around 70 moons each. So we don't see all of the moons, but just kind of the big name ones. All right. So that's about it. Hopefully you can look up tonight and find those 3 stars and our springtime constellations that are leaving on the 19th. Look towards the east early in the morning to find our very thin crescent moon and Venus right above the moon there. But I believe that is all I have for you guys today. Do check back our Facebook page. I think we are planning, I think Kate mentioned this, but we are planning to do some sort of like trivia game, like a live space trivia game with you guys if you want to log in and play trivia with us via Kahoot. But other than that, I'm good. Kate, is there any questions? Are there any questions?
No, I don't believe we have any questions or anything like that. If there is anybody who's watching right now who has a question, feel free to throw it in one of the comments below on the live stream, and I'll go ahead and answer your question. Or honestly, we can stay on here for just a moment and answer any questions that might pop up, or if anybody wants to send us a message or leave a comment, we can answer questions that way too. I'm going to be dropping below the links to our donation pages in the comments on both of our live streams right now. If you are able to, please do consider donating. These donations will allow us to actually create better live streaming video. So thank you so much, Ashley, and thank you so much to everyone else who was able to watch today. Hope you have a great rest of your day. Thank you.